So last video we were talking about the idea of how different planets have different densities. And if you remember, then we said this, that the planets Mercury, Venus, Earth, Mars, all of these are rocky. As to their consistency or size these are small. And similarly, the other four planets, Jupiter, Saturn, Uranus, and Neptune, these are gaseous and large. Now I kept that video separate and this one separate because this is in IGCSE, which is the accretion model, which explains these differences as to why some planets are like this, why other planets are like this, and it's not in O levels. So अब हम इसकी बात करेंगे. And the accretion model also explains as a whole how the solar system came about. Now this diagram is going to help us in figuring out कि accretion model जो है ये क्या कहता है about the formation of the solar system, how did it come about, and all of the related things. Alright. Now obviously we all know that the most important part of the solar system is the sun itself. So first of all ये बात करते हैं कि sun कैसे form हुआ है. So जहाँ तक accretion model की बात है, the idea is that the accretion model is a good enough theory and we have some proofs for this, that why this may work as an explanation and why it should be taught to students like you. So first of all, if we start from this first stage of the solar system, so right here we have something which is known as a nebula. और nebula का क्या मतलब है, what is it really? This is just some clouds of gas and dust. So before anything, जब कुछ भी नहीं था, so what we say is that there was this cold spinning cloud of gas and dust. This is what we call a nebula. So ये कुछ clouds हैं. Now what happens is that these clouds are basically all rotating in the same direction. And as the cloud is traveling, this is basically adding on to the cloud, the existing cloud, उसमें ये hydrogen और gas को gather किए जा रहा है. Right? So this cloud is getting denser and denser. फिर आपके जहन में ये सवाल भी आना चाहिए that at this point, what is really keeping the cloud together and what is not letting it all fly apart? Now इसका जवाब ये है, और ये जो आपको यहाँ पे ये inward arrows नज़र बने आ रहे हैं, the answer to this is that there is the gravitational force of attraction. So हमें पता है कि हर mass और masses को attract ही करेगा. So because of this cloud which has now gotten really big, और इसमें अब अच्छे खासे gas और dust particles हैं, these are being held together by the gravitational forces of attraction. And as the cloud is going round and round, इसमें इजाफा हुए जा रहा है. And then as a result of this gravitational force, यहाँ पे एक ring बनी जा रही है, which I hope you guys can appreciate. And this thing is then called a accretion disk. So now there's a disk, there's a ring of this cold spinning cloud of gas. Right? So this is now a ring. But आपको ये अंदाज़ा भी हो रहा होगा that as more and more of the gas is being added onto this accretion disk, so there is now more and more, and mainly the gas is hydrogen, which is being accumulated here. Now as the hydrogen gas is coming in and it's adding onto the cloud, the hydrogen molecules will also collide with one another. This is going to cause a increase in temperature. So यहाँ पे जो आपको बीच में ये चीज़ नज़र आ रही है, this thing right in the middle, this is now going to be the cause of the formation of a star. So in the middle we have this hot ball of gas. So and the technical term for this, we'll also study this in a while when we talk about the life of stars. This is called a protostar. So protostar का मतलब है this is now about to become a star. It's a prototype of a star. So now as this cloud is going around, this is still adding on to the cloud itself. अभी भी hydrogen gather हुए जा रहा है. So since there is more mass, there is also more gravitational force of attraction. But as the hydrogen gas is coming in, यहाँ पे ये core के temperature को भी और ज़्यादा बढ़ा रही होगी. So often this is asked in your exam, कि in terms of forces explain how this is going to work out. How is the new star going to be formed? So the idea is that often the examiner asks this in terms of forces. So यहाँ पे idea ये है कि जो gravitational force of attraction है अंदर की तरफ, so the gravitational force of attraction which is keeping the cloud basically intact, अब उसको oppose कर रहा होगा an outward force from the core which is basically due to the high temperature in the core of this protostar. So this is now because of these collisions which are going to be taking place, ये बाहर की तरफ एक force exert कर रहा होगा. When a stable star is formed, such as the sun, in this, so first of all let me label that this is also the protostar, this is also the protostar here, ये जो center में है. So in a stable star, ये तब होता है when the outward force due to the temperature, this is balanced out by the gravitational force. Alright, तो जब ये और gravitational force बराबर होती हैं, then is formed the stable stars such as the sun. So right now the sun is in a stable part of its life, but as we'll study later, stars also die, pretty much like humans. Now you might also be thinking कि outward force कैसे आती है भाई यहाँ पे? हमने तो पढ़ा है temperature is kinetic energy, so ये force में कैसे तब्दील होता है? Now the idea is this, that we'll also be talking about this later when we talk about the formation of stars. लेकिन यहाँ पे in the sun and in many other medium-sized stars, होता ये है that there is the hydrogen nuclei together which is fusing to give us helium. So यहाँ पे hydrogen is adding up to give us helium. इस process का नाम था nuclear fusion. And nuclear fusion also releases a lot of energy. And this is what is going to basically exert the outward force due to the high temperature. And जब ये force is going to be equaled by the gravitational force which is pulling it inwards, this is when the star becomes stable. However, ये समझना बहुत ज़रूरी है कि even when the star has formed, when the star has become stable, ऐसा नहीं है कि जो बाहर आपके पास ये पूरा डिस्क था ये पूरा ही ख़त्म हो चुका है. Because if you think about it, into the making of the stars, सबसे main चीज़ तो this fusion of hydrogen into helium था. So gas इसमें अच्छा खासा गया है, लेकिन बाकी चीज़ें, so there are still some clumps of gas and rocks and some dust which was left from पहले. This is still going to be here. Now again, these things also have a mass. So इनके mass की वजह से इन पे जो gravity act कर रहा होगा, यहाँ पे अब बनना शुरू होंगे clumps. So now all of this stuff is going to gather together. So यहाँ पे अब आपके पास बन रहे हैं ये सारे clumps. को नज़र आ रहे हैं यहाँ पे कहीं कहीं पे. This is concentrated a lot. A more technical name for these clumps would be protoplanets. जिस तरीके से stars का prototype थे, उनकी formative stage का नाम वो दिया गया था. अब जो planets form होने लगे हैं, इनके formative stage का नाम दिया जाता है protoplanets. Now let's tie this in back to where we began. हम लोगों ने क्या समझाना था आज? हम लोगों ने ये समझाना था why are the inner planets rocky and small and why are the outer planets large and gaseous. Now basic logic ये dictate करता है कि that out of this cloud of gas and dust which is still there, there is some of these clumps which are very close to the sun and then there are some which are further away. अब अगर हम लोग ये हल्के हल्के लाइट मॉलिक्यूल्स की बात करें, जैसे कि हाइड्रोजन हो गया, हीलियम हो गया या वाटर हो गया, close to the sun the temperature is way too high for these to exist in a solid form. So what the sun does is that exactly like how you and I blow on a candle, this blows these lighter elements away. So lighter elements blown away. क्योंकि देखें ये करीब वालों में तो एग्जिस्ट ही नहीं कर सकता सॉलिड फॉर्म में, ऑब्वियसली बिकॉज दिस इज सो क्लोज टू द सन. पहले क्यों थे ये यहाँ पे? बिकॉज एट दैट टाइम द सन वॉज नॉट दैट बिग एंड इट वॉज ऑल्सो नॉट दैट हॉट. But then as it got hotter, then it becomes too hot for these elements like hydrogen or helium or water to be so close to the sun. And the technical term for this is that the solar wind blows जो इन्हें यहाँ से धक्का देकर यहाँ बाहर की तरफ ले आती है. So this is why Mercury, Venus, Earth, Mars, ये planets which are much closer to the sun, इसमें आपको ये lighter elements नहीं मिलते हैं. So this is why these planets are small and rocky. क्योंकि फिर inner planets ऐसी चीज़ों से बने हैं जो in high temperatures पर भी solid हैं. इसी वजह से हमें अर्थ की कोर्स में ये metals मिलते हैं, आयरन मिलता है, silicates मिलते हैं. लेकिन if we talk about things which are pretty far away from the sun, तो जो बाकी 4 planets हो गए, Jupiter, Saturn, Uranus and Neptune, इनमें क्या है कि यहाँ पे now these are very far away from the sun and these are relatively cooler. So यहाँ पे वो सारे जो light elements थे they can now exist in a solid state. जो वो यहाँ पे नहीं कर पाए थे sun के करीब, वो यहाँ दूर पे ये कर सकते हैं. और फिर जिस तरीके से even though after the formation of the planets they keep rotating, अब ये इतने बड़े हैं that they can even capture the lightest elements. हाइड्रोजन हो गया, हीलियम हो गया, सबसे हल्के वालों को भी ये अट्रैक्ट करे जा रहे हैं. इस वजह से दिस इज द एक्सप्लेनेशन फॉर इट दैट द आउटर मोस्ट प्लैनेट्स आर लार्ज एंड गैसियस whereas the ones which are closer are small and rocky. Now where do we get proof that the accretion model actually works, that this is actually a plausible explanation for solar system किस तरीके से वजूद में आया? So the first answer to this is the idea of carbon dating. ये ऐसी चीज़ है जो आप लोग न्यूक्लियर फिजिक्स में ऑलरेडी पढ़ चुके हैं. And the idea is that when we took rocks from either moon or earth or Mars and when we tried to find out their age from carbon dating, which is basically the process जिसमें हम एक रेडियो एक्टिव कार्बन आइसोटोप कितना डिके हो चुका है उसकी मदद से वी ट्राई टू एनालाइज दैट हाउ ओल्ड दिस ऑब्जेक्ट माइट बी. ऑल ऑफ दीज गिव अस द सेम आंसर दैट all of these objects on all of these different bodies, they are approximately 4.5 billion years old, give or take. So this is the reasoning for this. This is the scientific proof for this. बाकी जो इसका दूसरा proof है, it's somewhat more logical. वो ये है that we know that all planets and all जो भी हमारी सारी चीज़ें हैं हमारे solar system में are all rotating in the same direction. In the same direction and also in the same plane. This cannot be a coincidence. So if everything is moving in the same direction, this gives more proof to this idea कि शुरू में all of the accretion disk जो था, ये जो पूरा nebula था जिससे हमने start किया था, this must have also been rotating as a whole body in one direction. And then all of the things that we just talked about, फिर उस order में ये सारी चीज़ें हुई होंगी. Another important point to keep in mind, I'm pretty sure we've written this down previously as well, but anyway write it down again, which is that आपका जो solar system है इसमें हर चीज़ sun को orbit कर रही है. इसकी वजह ये होती है that 99% of the mass of the solar system is the sun. सही है? So 99% of the mass is in the sun itself. इसी वजह से जो ये दूसरों पे force exert करता है, this is so strong that it makes everything orbit it only. So that's it for this video. See you in the next one.